Okay, so we're given two functions, f of x, g of x. We're finding g of f of x. So we know that this is function composition, and this is g of f of x. F of x is on the inside of the parentheses, so that's the function we're plugging into the other function. So we locate f of x. There's our function f of x. We're plugging it into function g wherever there's an x. So instead of an x there, we substitute in 3x plus 1, right? So we have 3x plus 1 squared minus 5. Any questions on where that substitution was made? And now I had someone a teacher tell me that their honors kids were just squaring this and squaring this. 9x squared plus 1. Is that how we do that? No, we know that's breaking the forbidden rule. So we rewrite this as 3x plus 1 times 3x plus 1. And then we won't forget our minus 5 out here. So then we would double distribute 3x times 3x. 9x squared, 3x times positive 1 is plus 3x. 1 times 3x is plus 3x. And 1 times 1 is positive 1. Then we don't forget our minus 5. Combining all like terms, we have 9x squared, no other x squared, plus 6x, and then negative 5 plus 1 is negative 4, right? Minus 4. There's our final answer. Questions on that? How many got it right? Yeah, you guys are awesome. Okay, let's get going, guys. I know it's a Friday, but it's a regular day of school. So, we are actually not learning a whole lot new. We're going to keep practicing some of the stuff we've learned. We will learn a little bit new. I mean, just apply some new things, but nothing super new today. So yesterday we learned how to find the area of full circles and then how to find the area of just a sector, which means just a section of a circle. So remember that area of a full circle would be pi r squared. That would be filling in the entire circle. And then remember, area of a sector just means we only want an area of a certain section of the circle. So it's still pi r squared, because area of a circle is pi r squared. But now we're considering we only want this theta, this degree measure out of 360. So this degree measure out of the full circle, right? So it's pretty easy to hopefully remember. Theta over 360 times by pi r squared. And once again, in the formula it's still pi r squared, that's area of a circle, but now we're just considering we only want the area of this section out of the full circle. So theta out of 360. So once again, make sure that you're using the theta for the section that you want to find this area of the sector of. Don't use the wrong theta. So if I said find the area of the highlighted region, you wouldn't use this theta. You wouldn't use that angle measure. You'd use what entraps the sector. Okay, so number 9. I'm going to do most of my examples off your worksheet so you have less to do. Okay, so number 9, it says find the area of the shaded sector of the circle. Leave your answers in terms of pi. So we want to leave our answers in terms of pi, because that's a mathematician would want that answer, because it's an exact answer. So you say to yourself, okay, so I am finding area of a sector, which just means section of a circle. So then you say to yourself, I know the area of a full circle is pi r squared. Well, now we're doing area of just a section of the circle. So we know that its area is equal to theta over 360 times by pi r squared. So let's plug in. What's our theta in this one?
90.
90 degrees, right? That little square means 90 degrees. Questions on why that's 90 degrees? Okay? So we want the area of that 90 degree piece. So we have area is equal to 90 over 360 times by pi times by our radius squared, so 4 squared. And then we know with multiplication, we multiply straight across. So this is technically all divided by 1, so we multiply straight across. Now we want to leave our answer in terms of pi. So we would not type in pi to our calculator. And then with multiplication, can't we reorder it in any order? Yeah? So can we essentially go 90 times 4 squared times pi on top? Yeah, I just reordered the top, right?
Yeah.
Which is fine. And then divided by 360 times 1, which is just divided by 360. So type it into your calculator. We have 90 times 4 squared, which is 1,440, divided by 360. 4? Okay? So that leaves us with 4. So 4 over, this became 4. So we have 4 pi, right? We won't forget the pi. I noticed a lot of you that handed in your assignments yesterday forgot to write pi. If you don't write pi, you're wrong. The pi was there, we just didn't calculate it in our calculator because then we can't put it back in a fraction. So 4 pi, and then was there any measurements on that? Nope. So 4 pi. Questions on that? Okay. So number 14. Let's do number 14. Okay. So looking at this, it says find the area of the shaded sector of the circle. So looking at your picture on number 14, we want this shaded sector, right? So don't we need theta of that?
Yes.
So let's look at our picture and see how could we get that.
180. Half a circle is 180, so it's just extrapolating from 180.
Okay, good. Tyler, I like how you explained it in very good detail. Tyler said there's a straight line, right? A half a circle. So those angles should add up to be 180. So you'll do 180 minus 120 to see what's left over. So what do we get? 60 degrees. So the theta we're using for that piece of that shaded region is 60. So we know area is equal to theta over 360, that piece over the full circle, times by pi r squared. Our theta is 60, so 60 over 360 times pi times by our radius squared. Careful. In the picture, are we given the diameter?
Yes.
So the diameter is 12, therefore what would the radius be?
6.
So this is 6, so our radius is 6. So pi times 6 squared. So now we'll just type it into our calculator. 60 times 6 squared divided by 360, which is 6. So we get 6 pi. Now, once again, order doesn't matter. You could also type it in 60 divided by 360, hit enter, then multiply by 6 squared. Because remember, order of operations, division and multiplication are equal, right? Order of operations. One doesn't come before the other, right? So in this particular instance, we could divide first and then multiply, or multiply first, then divide. Okay, questions on what I mean by that? Okay. So do 9 through 17. All right, so I just want you to remember to find the area of a right triangle. Now, right means a 90. It contains a 90-degree angle. So in these two pictures, this is considered a right triangle. Technically, two right triangles, but you can find the area of it has a right angle in it, and then this has a right angle in it. So this is the formula for finding the area of a right triangle: 1/2 times the base times the height, where the bottom part's the base and the height is this, right? Everybody? So right here would be my base, my height, my base, my height, okay? Area is the same for both. So you don't need to change anything for either of these, because a lot of people will say, well, don't I have to take this one and divide it by 2, or like they'll get kind of confused. They're like, why are the formulas the same, the triangles look different? But it's because the base will be smaller in this one, right? So it would only find the area of this, where the base on this one would be the full amount, so it finds for both. Okay, so the formula is the same no matter what. Okay, so now we're going to be asked to find the area of the shaded region. Okay, so we've got to think of this in pieces. So everybody look at the shaded region. We want to find the area of just this piece. So if you think about it, do you see how we have a sector here? A section of a circle, right? Do you see that? If I filled in this whole piece, wouldn't this be the area of a sector of a circle?
Yeah.
Okay. Now, couldn't we also find the area of this triangle?
Yes.
Now, so if we took the area of the full sector and subtracted off the area of the triangle, wouldn't that leave us with the leftover?
Yes.
Yes. So that's what we're going to do. Okay. So we're going to have to do two pieces here. So the first thing we're going to do is find the area of the full sector. So area of the sector. I'm drawing a sector, just so we can keep them straight, okay? So area of the sector. So first of all, that would be the red piece, right? The full red piece. So let's find the area of that full piece. Ignore the triangle if we are filling in that full piece. So that would be 90 over 360 times by pi times by our radius squared, right? So our theta was 90 divided by 360 times by pi times radius squared. So the area of our sector, let's calculate it, and let's leave it in terms of pi. I don't have my calculator, so go, tell me.
100.
What is it? Sorry, I have to speak really clearly. What?
Get a meter. 1.
You got 1?
Yeah.
90 divided by 360 times by 2 squared. Okay, so you got 1. So that would be just 1 times pi, right? Okay, awesome. Now let's find the area of our triangle. So remember, we have a right triangle here. So now I'm going to change colors and go to green, because that would be the triangle. So now we'll find the area of our right triangle. So I just draw it in so I can keep them straight. Okay, so we know area of a right triangle is 1/2 times the base times the height. So that's 1/2 times our base, which is
2.
2, and then what's our height? It's 2. Why do you know it's 2?
Because they're divided.
Oh, because they're the same.
All of them are 90 degrees.
The radius comes from the center of the circle.
Okay, Carter perfectly said. If this is a radius and goes to here, if we draw a radius here, is it going to be different? No, so if this is 2, wouldn't this be 2?
Yes.
Okay, so our height is also 2. Way to see that, okay? Does everybody understand why we knew that for sure? A radius is a radius no matter where you draw it, so if the radius is 2, it's 2 right there as well. Okay, so tell me what the decimal value of that is, or the number.
2.
Right, because that would be 1/2 times 2 times 2, that's 4 times a half, or that's 4 divided by 2, which is 2. But you could just type it into your calculator, right? So now think about it. Is everybody following me still? Have I lost anybody yet? Okay? So now to find, once again, the area of this shaded region here, we're going to take the area of the sector and subtract off this area of the triangle. That would give us the leftover. So we'll take the area of the sector, which was pi. So we're taking pi. We're subtracting off the area of the triangle. And everybody understands why, right?
Yes.
Okay? So that would be -2. So now you'll type that into your calculator, and this is going to be a decimal answer. So what's the area of that shaded region? Go pi. Make sure you use the pi key.
1.1415.
1.14. That's probably, we'll round to 2 decimal places. Agreed? Okay, awesome. So that's 1.14. That's the area of the shaded region. Questions on that? Okay. Okay, next one, last one, and then I'm just going to give you the rest of the time to work, but pay very close attention. Same thing here, but we've got to think about this one a little bit more. Okay, so it says find the area of the shaded region. So once again, we have a full sector here, right? All this stuff, right? And then we also have a triangle, all this stuff. So if we took the area of the sector and subtracted off the area of the triangle, then we would know the area of the shaded region. So let's find the area of the sector. So area of the sector is theta over 360 times pi r squared. So that's, what's my theta? 60. So we have 60 over 360 times pi times radius, which is 4 squared. Okay, go. I got 2 different answers, so a couple people more calculate it, make sure. Recheck your work. You got 8 pi thirds, okay. So we have 8 pi thirds, so that's just the area of the sector. Now, we want the area of our triangle. Right now, as it's drawn, we have this, okay? So we have a triangle with a 60 degree and a 4 right here. Do we have a right triangle? No. Huh, interesting. So we've got to actually think this one through a little bit. Okay, so let's think about this. Let's look at the picture up here. If this is 4, won't this be 4? Okay, right? Everybody? We're all good, right? Now let's think about it. So if this side's 4 and this side 4, won't this angle, because it's across from that 4, and this angle must be the same, correct? Isn't that true? If the sides are the same, won't the angles be the same? Okay, so let's take our calculators and do 180 minus 60. How much angle is left between these two? 120. Okay, so we've got to split 120 evenly because these are equal angles. So what are those angles? 60. So this angle is 60, okay, and this angle is 60. Okay, interesting. Okay, let's see. I think that will help us. All right, now, couldn't I choose to drop a line straight down and create a 90-degree angle? If I drop it perpendicular, wouldn't that create a 90-degree angle? Okay, so now I'm cutting this and creating a 90-degree angle here. Now don't we have a right triangle?
Yes.
But so we need 1/2 times the base times the height. Okay, so one more thing. Sorry. If this is a 60, 60, 60, isn't that an equilateral triangle? So this side's 4 and this side's 4, what's this side? 4. Is everybody good with that? So, if I drop that line perpendicular, wouldn't it cut it in half evenly? Yeah, so what's this side? 2, what's this side? 2, okay. So now we have a right triangle. My base is 2 right here and 2 right here. What's my base?
4.
4, okay. And then what's my height? We don't know. We don't know, do we? We have no idea. But haven't we learned right triangle Pythagorean theorem and right triangle trig? Okay, so I'm just going to use, since we know this side's 2 and this side's 4, can't we find this side?
Yes.
Pythagorean theorem, right, everybody? So let's do that. So we know we have a right triangle. This is 4, this is 2. We want to know the height, right? So when we go side 1 squared, question mark squared, plus side 2 squared is equal to the hypotenuse, which is 4 squared, right? So let's see what question mark is. Guys, what's question mark squared? So
3.46.
So we have 4 squared, which is 16, right, guys?
Yes.
And then wouldn't we be subtracting 4? What's 16 minus 4?
12.
12, okay? Then don't we take the square root?
Yes.
So we have question mark is equal to the square root of 12. Now, we probably want an exact answer, so wouldn't we break this down by hand?
Yes.
So this breaks down into 4 times 3, this breaks down into 2 times 2, right?
Yeah, it's broken.
So we pull out a 2, right? So 2 square roots of 3. So this height is 2 square roots of 3. So now we can find the area of the right triangle. So area of the right triangle is 1/2 times the base, which is 4 times the height, which is 2 square roots of 3. Yes, I need some room so I can have that written. So 2 square roots of 3. So what is the area of the triangle? 6.928. Okay, awesome. So now to find the area of just the shaded region, I'm going to give myself some room here. We would do the area of the full sector minus the area of the triangle. And a decimal answer is okay at this point. So the area of the sector was 8 pi thirds. So we take 8 pi thirds minus the area of the triangle, which was 6.928. So calculate that, and there's our area of the shaded region.
1.44.
What was it, sorry?
1.44.
Sorry, say that again.
1.44.
1.44. Did everybody get that?
Well, it would be 1.45 because it's 1.45.
Okay, perfect. So 1.45. Good. Sweet. Questions on how to do that one? A little bit trickier, right? Took a little bit more thought. Okay, awesome. Okay, so these are the ones you're doing. So really, the only one you're crossing out is number 20. There's no, you guys won't have a way of doing that. So this is actually the secondary 3 worksheet. Cross out number 20.